using min and max functions when you're using variables. So we do have this code here. Let's copy and paste it to our learning Python file. All right, so we have variable A assigned a value of 15, variable B assigned a value of 9, and variable C assigned a value of 20. And we're trying to look for the lowest here in these values, right? So we're saying our variable lowest equals the minimum of these three values here, A, B, and C. And then our highest is the max of these three values of variables, A, B, and C, right? And then we're going to go ahead and make a function call to Python to print the lowest value, right? So print lowest as variable lowest, and then print highest as variable highest, right? Remember, we've already calculated the variables lowest and highest using these functions here. All right, so we're going to go ahead and run this one. And as expected, we see on our console here that Python has printed that our lowest value is 9 and our highest value is 20, right? Let's go back to our notes. Let's look now at another example where we're trying to get the minimum and max scores as well. So here we have three score values, right? We have three variables assigned values. So score 1 is assigned a value of 0.8, score 2 a value of 0.65, and score 3 a value of 0.92. Same as the previous example, we would create a variable for our best score, so we're calling it best underscore score equals, and then we'd use the max function equals max of these three variables, and we'll put them in the brackets, and then would calculate the worst score as well. So variable worst score equals using the minimum function equals min of these three variables, score 1, score 2, and score 3. And then we'll go ahead and print onto the console. So print best score being best score variable, and then print worst score being worst score variable, right? Already calculated over here. And when we run this one, our expectation is that we get these values here, and sure enough, we do get the best score as 0.92 and the worst score as 0.65 printed onto the console. Awesome. So just as a quick note, min and max become more useful as you work with lists and other collections, as we'll explore later. But like we've already said, there is no limitation as to the amount of data that you can work with, right? So these are great when you're dealing with huge lists that you cannot really peruse through individually, and you want to, in a way, automate the calculations so that your user can get the feedback promptly. For whatever they're obviously calculating for. Let's look at math modules now, right? So Python has a standard library with many extra numeric functions, and you can always call these libraries depending on the one that you want to use at any particular time. So what libraries are essentially code already written by other developers over the years to achieve certain computations or calculations. This, in a way, helps any dev in that they don't have to write that code over and over, right? So that's where the phrase don't reinvent the wheel gets used a lot, right? You don't want to be writing code that someone else has already written. So instead, you can always call it in Python in your own code and use functions to sort of like run those calculations or compute on your within your code on your computer. All right, so when we are using the math module, we often have to first call it before we actually use it, right? And the math module gives you advanced math functions like square root, factorials, and constants like pi. So we're going to use these quick examples here. I'll just copy and paste this into our learning file so that we can go through it in detail. I'll just remove this since it was just a note to explain this a little bit to you. So I'll just remove this one here. All right. Okay. So first things first, we import math, right? And then math square root x. This one is a function used to calculate the square root of any number, right? Since we've already imported math, I'll go ahead and remove this one. And now we're saying, okay, we're asking Python. Essentially, we are making a print function call, and we're also saying print using the square root function from the math module, print the square root of the value 9, right? So we'd expect a value of 3.0, and then we're also printing the square root of 16, right? Let's go ahead and run this code here. And right here at the bottom, we can see in our console that these two values have been computed to be 3.0 and 4.0 as floats. Another one, let's assume we have a variable 2, right? And we're trying to get the square root of that value, right? So we would say the square root equals math dot square root. Notice that we always use dot, right? So the dot, in a way, is sort of calling this function square root from the module math, right? So we're saying root equals math dot square root of this value, which we have already assigned a value to. And then we'll go ahead and make a function call to Python to print that root onto the console, right? We already ran this code, and notice that the value that we got was 1.41. So if you multiply this number by itself, then you'd expect to get back a value of 2. So math square roots essentially require the x to be a non-negative number because typically we don't calculate for square roots of negative numbers, although that's a problem that mathematicians can go on to sort of navigate. But for us, for the realities of projects we're working on, we're expecting the values to be positive. And just to kind of show you what I meant by that, if we go on and change these values to negatives, we would expect an error to be thrown because Python isn't written to calculate square roots of negative numbers, right? So immediately we can see that a value error, math domain error, is being thrown to us. All right, let's go ahead and look at other functions. This one is essentially using the math.pi function, right, which is used to essentially get the value of the constant value of pi, right? So this is great if you if you're calculating areas of like circles. And again, just a quick example. Of course, you could be using it for more complicated projects. But first thing that we would do is import math, and then would print the math.pi. Since this one already has a value assigned to it, it would return a value of 3.14. If we were to calculate an area of a circle, right, we would of course need to first get its radius. So given a value of 2, area would be calculated as math.pi, so calling that that pi value, right, itself as a function, and then multiplying it with the rest of the equation, right? So the radius, which was already assigned a value of 2, and to the power of 2, and we would go ahead and make a function call to Python to print the area. And if we're to run that, would get our values as 3.14 for the pi, and then 12.56 for the area of that circle. So as noted earlier, math.pi is just a constant provided by Python, not a function, right? So that's the reason why we did not use parentheses in this code here, right? Whereas prior, if we're using, if we're calling for example, square root, then we would have to use essentially would have to use the parentheses. All right. We're going to look at another example here, and this one is just to calculate distances. And right now we're just sort of mixing what we've already learned and doing a couple more examples just to get you practicing a bit more and learning the foundations of Python so that you can get more advanced code in the next modules. within this playlist. All right, so let's assume that we start at a certain point. Let's call that point -3, and we end at another point. Let's call it 7, right? +7. So we have our two other variables already given the values, and now we're calculating for the distance, right? So we would say the distance is equal to the absolute, right, of the absolute value of the end minus the start, right? And then we'll print distance to our console, right? Um, since this is 7 and this is -3, that would end up being 10. And if we run this, Python as well, that's computed to be 10, and it makes sure that it's a positive value because we're more interested in the change in the distance, right? That's why we're using the absolute, so we don't have negatives being returned. Okay, let's look at another example here, and this one is also still using the import math function and mixing in whatever we might have learned earlier. So for this one, we're importing math, and we have two values. Value x has a value, variable x has a value of 2, variable y has a value of 5, and we are calculating another variable called value. So we're saying value is equal to the square root, right, using the math module of this expression here, x squared plus y squared, like a hypotenuse essentially. And then for the next variable, rounded value, we essentially instructing Python to round this value here calculated, to round this value to 2 decimal places, right? That's why we have the 2 here. And then we're telling Python to essentially print the exact value and also to print the rounded value. So let's go ahead and run this code, and surely enough, here for the exact value, we have the 5.35 with all the decimal places. And for the rounded one, we're only ending up with 5.39 because it's been rounded off to the 2 decimal places that we did emphasize earlier. All right, that in a way dives into all the operators that we've looked at, and also introduced other math functions as well. Now we'll just kind of explore a few errors that are often made by beginner devs whenever they're writing code. A few of them are when you're using libraries. We tend to see cases where devs will often not assign values or put expressions in parentheses after they call the function. So for this one, result equals math.sqrt, you'd expect that you would write an expression, right, such as math square root of 2 to the power of 4, for example, or 54, whatever the value is. So that would be the right one. But doing it this way would, just like this, would result in an error, right? And if we were to try this as well, you'd note that when you run it, Python itself is going to not, okay, so we did not print this. I'll just go ahead and say print result. And I'll run this again. And notice that it just says this is a built-in function of square root, right? But it does not calculate anything. So you would have to add whatever you're calculating after this. So for example, if it was 9, then if you run this, the function would actually then go ahead to run that. So just make sure you don't forget your expressions. Another thing is the use of this caret value instead of the 2 stars or power for calling or for calculating the square root. So this one here will be wrong, right? Print 2 to the caret 3. This is not 2 to the power 3. You'd end up with a value of, for example, 1 instead of actually getting a value of 8. And the reason, so you see here it's saying 2 to the power 3. This is a bitwise operation, and it's not essentially power, right? So it's correcting it here and saying instead, if you want to calculate the power, you'd have to use 2 star star 3, and that would be the exponentiation, and the value that it returns is the value of 8. All right. That's it for some of the examples. Another one is essentially forgetting calling or importing the library that you're going to use, right? So if you forget to import the library, if you use this, it's going to essentially tell you that math is not defined, or it's not being called, right? Because it has no idea of what math you're trying to call, right? So uh, right there, you can note that on our console, it's showing that there's a name error. Name math is not defined. So to correct this, you'd of course have to first import math, and then after doing that, then you'd actually go on to use the functions, and if you use that, that should be able to work correctly. All right, I'd put together other pieces of code to practice with, but for this one, we're just going to go through it to know how it works, since we already have the values either way written. So if we had three variables, right, one with negative value, so negative 10, 4, and 7, and we're calculating these three values from them, right? So val1, val2, and val3. For val1 being an absolute of A would expect it to compute as negative 10 made a positive, so that value will be 10. And for val2, mean of A, B, and C, would expect that value to be negative 10. And for val3, max of A, B, C, would expect that value to be 7. And let's try running this code here and running it. And right here, oh, we did not print anything, so that was my mistake. So I'll just go ahead and add the print command here. Just remember to close your brackets whenever you do. Here it already, since I'm using autocomplete, it already knows that I'm trying to print all of these ones, so it suggested that. I accepted it. And right there on our console, we do see three values being printed, value 10, value negative 10, and value 7. All right. The second example was using a price. So it says price is a value of 12.3456. And we're trying to round that up, right? So we'd say the final price that's actually shown to the customer or client is going to be the rounded value of this price variable um, times um, a value of 1.2, right? So maybe this is your purchasing price, but this is your selling price. And then we also want to essentially make sure it's only showing two decimal places when it's showing the final value to the customer. So let's run this one here, and notice that it would go on to print that. Actually, we did not call for print, so let's write that. Okay, so I would say print final price, right? And if we run that one, it should be able to then print the value of 14.81. So this is 14.81 is the value at which you'd end up selling your product. And again, you could use this code to essentially create a project where that is used by any store, right, for determining prices at which they should mark up all items that they purchase. So for every item that comes through the door, you just enter the value it was purchased at, and you'd multiply that price by this one, and you'd have um, the final price calculated for you for as many products as you want, right? Okay. All right, this one we're not going to do because we've already looked at that. So you can just definitely pause this one and run it on your own if you would like to. But if you have any questions, just feel free to share them in the comments. Also, be sure to watch the next video in the playlist to advance your Python skills. As always, the playlist is arranged to help you learn everything that you need to know about Python from beginner to advanced. So just be sure to follow through and ask where you have questions, and this should be enough to get you hired or to build your own projects or collaborate with other teams. All right, I'll see you in the next video.